All right, guys, we are back in my garage for another video, and today we're going to be talking about how BMW reinvented the engine thermostat. Yes, the engine thermostat is something that was pretty well proven. You know, it's something that we've been using for decades, and everybody already knows how to upgrade them, how to replace them, how to maintain them. But BMW said, you mere mortal, you think you know what's best, but we can do whatever we want. So we're going to do whatever we want. And we did whatever we wanted again. And you're just going to deal with it. Yeah, sorry about that. But they reinvented the thermostat and created the heat management module. And what the heat management module does is it is a really unique way to help direct coolant wherever you need it to go, depending on your driving circumstances and the engine demand. So it's really unique setup, something that came out with the B58 engine. And since we have a unique opportunity to take a closer look at it, I just wanted to talk a little bit more about what it does, how it works. And of course, we'll jump over to my B58 engine and take it off to see exactly how it looks inside. So let's go ahead and talk about it, and hopefully you guys find this video useful. So if you haven't seen my previous videos, we're working on a B58 engine that came out of my 2016 340i. I bought it from Copart with engine issues, but instead of fixing it, I decided to test my luck. And after making over 600 wheel horsepower for the past several years and a bunch of weekends of track abuse, unfortunately, my luck ran out. So I'm tearing down the engine to find out what went wrong, and in the process, I'm making videos like this one to take a deep dive into some of the engine's internals. So check out the playlist in the video description for all of the videos I've made, and don't forget to subscribe for more videos like this in the future. So when you're looking at a traditional cooling system, it's actually pretty straightforward. You've got coolant that you need in order to keep the engine from overheating. So the way that we make that happen is we have a water pump, and the water pump pumps coolant throughout the engine so that heat can get pulled out of the engine and into the coolant. And then that coolant flows through a radiator, and as air flows over the radiator fins, the air pulls the heat out of the coolant. So that effectively cools down your engine to make sure it doesn't overheat. But as we all know, and we've talked about on this channel, colder isn't always better. You don't want everything to run as cold as possible. There is an optimal operating range for everything, including your engine. You want it to get up to temp so that it runs as efficiently as possible. You want, good gas mileage and everything to seal up properly. You want a good safe range for your oil where it performs optimally. And of course, just from a comfort standpoint, you use that coolant to heat up inside of the car. So especially in winter, you need the coolant to get up to temp as quickly as possible so that you can get some heat in the car just from a comfort standpoint. So that's where the thermostat comes into play. And the way that the thermostat works is it seals off coolant going to the radiator so that it doesn't actually get cooled down. So there's a period of time where you first start the car, all of the coolant just stays in the engine, and the engine basically is heating it up without it being cooled off. And once you get up to a certain temperature, then the thermostat will open up to let coolant go to the radiator so that it can be cooled down again. Now, the thermostat is going to have a set temperature range. So you might have like a 200-degree thermostat. And when that opens up at 200 degrees, coolant will begin to cool down. And if it drops below 200 degrees, the thermostat will close again. So it can open and close whenever it's needed to help keep everything in that safe operating range. But you can always change your thermostat out. They come with different temperature ranges. They might be 180 or 160 if you want your car to run colder. It really just depends on what you're using the car for. Now that applies for mechanical thermostats, but there are also electronic thermostats, and those are basically open or closed depending on the engine control unit telling it to open or close. So that can be depending on coolant temperature or a lot of different things as well. So BMW saw the thermostat blueprints and said, hey, I know that's been working for decades, but throw all of that out the window and we're going to create the heat management module. And what that is it's basically a plastic housing that bolts onto the side of the engine, and it has a rotary valve inside that can direct coolant through different veins and outlets depending on what you're doing. So it can basically turn that rotary valve to open and close the different outlets so that you can make sure you're getting heat into the engine or to your heater core, or blocking everything off similar to how a thermostat functions, just with a lot more control over exactly what it's doing. So with the heat management module, there are 4 main stages. The first one is the cold start stage, and this is where everything is sealed off. So you still have a similar functionality to the thermostat being closed, where all of the coolant is staying inside of the engine circuit. Then you have the warm-up phase, and what this does is it opens up coolant going to the heater core. So it's warm enough where, it's above ambient temperature. It might be 60 or 70 degrees, enough to warm up the car when it's cold, but not warm enough to where you want the engine to stay at that temperature. So it's only opening up outlets to send coolant to the heater core to get you a comfortable cabin as quickly as possible when you're driving your car. And then you've got the operating temp phase. So this is where everything is open. It's sending coolant to all the radiators, your heater core, basically every opening inside of your coolant circuit is open and coolant is flowing freely. So this is basically keeping the engine at operating temperature under normal circumstances. But there is a fourth stage called the maximum cooling requirement. And what this does is it bypasses the short circuit coolant line that basically sends coolant bypassing the radiator, and it also reduces how much coolant is going to the heater core to maximize the efficiency of getting heat out of your coolant. So this is when you're running max cooling mode, like we've talked about in previous videos, to make sure that the coolant is cooling down the car as much as possible, and you're directing as much coolant to the radiator as much as possible. So I think this is a pretty cool thing to think about, how it all works and how it can direct coolant flow. But of course, I want to see exactly how it works for myself. So let's go ahead and hop over to my engine. We'll take the heat management module off and take a closer look at the internals. All right, and here it is. So this is the heat management module, and basically all of the main functionality of our cooling system is in this kind of general area. So what we're looking at is very complicated from the surface, but actually I would say pretty straightforward when you understand what's going on. So this is actually where the cold coolant comes in, goes back through here over to the heat management module, and then this works its magic to actually direct coolant depending on the driving situation and things like that. So we'll go into more detail on how this actually works, but this is basically the main component that's replacing your thermostat. Then coolant comes out into the water pump. So this is where your mechanical water pump is running and turning with the engine. That pumps coolant into the engine, and then it comes out up here. It comes out through here with the oil filter housing and basically everywhere else. So it's just kind of working constantly to make sure that coolant is going where it needs to be. I want to definitely take a closer look at it though. So let's go ahead and take all of this stuff off and we'll go into more detail. So the first thing we're going to do is remove the bypass hose on top of the heat management module. It's held on with 2 clamps, so go ahead and remove those with some pliers, and then you'll be able to pull the hose off. Next, we're going to use an E10 E-Torx bit to remove the 7 screws that are holding the water pump mount onto the side of the engine. I thought just removing these screws would be enough to pull the mount off, but it just wouldn't budge even with a crowbar without pulling the heat management module as well. So I hand threaded one of the screws back on just to make sure the mount wouldn't fall off, and then we removed the screws that are holding the heat management module onto the side of the block. Then with a little bit of patience, I was able to pull the entire water pump housing and heat management module assembly in one piece. This was mind-blowing to me because I was so sure that the coolant pipe that we see right here goes straight into the block, but as you can see, it's actually its own pipe that is just bolted to the side of the engine, and it actually flows directly into the heat management module. Interesting design choice, but that makes it easy because we can simply remove it by taking off these 4 screws that are holding it on, and then I pulled the entire pipe assembly off of the block as well. All right, so this is everything that we've taken off. So these are the bolts that we're holding on the water pump housing, I guess. And then these were a couple extra bolts that we had. But I think first thing first, again, this is our coolant inlet. So all of the coolant coming out of the radiators after it's been cooled down goes through this nicely manufactured / smashed flat pipe. And I actually thought that this went into the engine. I didn't realize that the outlet comes through this hole, and then it goes into this opening into the heat management module. This is our main buddy that we're going to be talking about. And then as it flows through here, it goes into this passage, and then the water pump is in here. So it's basically sucking up the coolant and then pumping it into these 2 outlets, which come out on this side. So that's kind of how all of this works. Again, extremely complicated compared to a more traditional thermostat, but I can understand the functionality here because this gives you a crazy amount of control for exactly where you want the coolant to go to make sure that the car warms up as quickly as possible, but also can switch to, you know, a high demand cooling situation depending on the circumstances. So this, we're going to move out of the way just because it takes up a lot of space. And then I want to take this apart. There we go. Definitely didn't want to come off, but yeah, so again, you can kind of see the hole when coolant comes out of this heat management module and flows through this big pipe. Then it goes through here directly into where the water pump sits. But otherwise, this is just an aluminum bracket, basically just a mount. So also we'll get this out of the way. So yeah, this is the main bad boy. Again, this is underneath the intake manifold. So the intake manifold's on this side, and then you've got the front of the engine, the front of the car over here, and then the rear of the car over here. And this just bolts onto the side of the block just like this. This is the motor that actually turns this housing or this vane control, I guess, in here, because this basically should have holes in it that as it turns, when coolant comes in here, it can direct whether it goes to the water pump or to the other auxiliary components. I think this one, I believe, goes to the heater core. I think this is the bypass, so when it basically skips everything, it bumps right into here. One of these, I think, goes to the other main radiators or one of the main coolant tanks. So yeah, let's go ahead and I guess we'll start with taking off this actuator so we can see how it controls everything. All right, and we'll take this off. All right, so pretty straightforward. So you can kind of see this is the keyed slot that goes onto this portion, and this is basically what turns the vane inside of here. So I was hoping it was just going to be like a square or something so I could easily turn it, but maybe this will work. Let's see. There, so that you can kind of see is basically how it works. So it turns open and can let coolant in and flow through as needed, or it can close or go basically any amount of variation between that. So that controls how much coolant is going through the heat management module and also controls, you know, where it's going. So you can control maximum amount of coolant flow, minimum amount of coolant flow, and the exit holes control which one of the outlets it comes out of. So it's hard to see, but actually in here, there are additional holes on the side. And so depending on where the holes line up, the coolant can actually flow through here and come out those holes, and then those control how it goes to the different outlets. It looks like maybe we can take this side off to at least see that portion of it. If you guys like seeing this stuff, don't forget to subscribe, man. I really do appreciate everybody that's been entertaining me as I take everything apart that I always wished I could, just to see the inside. You know, I'm just kind of curious, and not a lot of people have the opportunity to do this, so feeling pretty good. Maybe we gotta take off this side first. Here we go. Yeah, it's plastic inside too. I don't know what you want me to tell you. So now we can see the other side. So this was actually sealed up to this. So that basically was looking for a specific opening in the vane. So you can see over here, basically this big pocket is where this opening is on this side. And depending on how it's open, let's see, let's try to turn it, which way do we want to go? Let's turn it this way. And you can see it's starting to basically get to that point where it would let coolant out of this pipe, right? And then if we turn it a little bit more, you can also see down here, a hole is open, and that's letting coolant come up through this top side. I don't know why this won't come off to show it. It's going to take a lot of prying, but yeah, you can see there's another outlet there. So depending on how this is turned, it can either open or close the vein going here, which would basically send coolant. Again, I believe this is to the heater core. So once the coolant is warm enough, it'll send coolant to the heater core so you can get heat inside of the car, but it won't send it in there to make sure you're not getting cold air. And then if you turn it this way, now you've got coolant only through this port on the front, as well as some on the top. And then there's an additional hole. So this is basically blocking off the coolant port that's going to your water pump and only letting it out through these other holes. So yeah, man, this is really complicated. I think a lot of this is probably going to depend on knowing exactly what your car is going through. I mean, obviously this is how max cooling mode is controlled, because it can change how much this is opening and how much coolant it's flowing to reduce your engine temperature. But I showed you guys once I got on track, you know, it didn't really help a whole lot. Like, I haven't really had cooling issues on track, but turning on max cooling mode basically kept temps down while I was cruising, but still wasn't really enough to make a significant reduction on track, just in my experience. But yeah, this is how all of that works. So hopefully that makes sense and matches what we see in the pictures, you know, to kind of help you understand, depending on where these holes line up, that controls which of these ports are letting in and out coolant. And again, you can kind of see it better here. There are holes on this side to flow coolant out to the main water pump. So, you know, I think this is pretty cool. When this is blocked off, then it's not sending any coolant, or, you know, using the coolant coming from the radiator. So that's helping the car warm up a lot more quickly. And then you've got probably your max cooling mode here, where you've got, let me turn this all the way. So this will allow coolant through the radiator. It'll block off coolant going to the heat exchanger and still allow coolant to go to your auxiliary system. So that way you're not wasting any heat by sending extra coolant to the heat exchanger or to the heater core. You know, this is just only using the radiator to cool down the coolant as much as possible. Yeah. So this is cool, guys. I know it's a lot more complicated than a traditional thermostat, but this is pretty cool. So yeah, I think that's a pretty slick piece of technology, you know, definitely more complicated than it probably has to be, but it's cool to have all the capability that it does. And I think a lot of this also stems from BMW switching back to a mechanical water pump, because if they used an electric water pump for the engine circuit, then they'd be able to vary the speed and how much the coolant is flowing through the engine depending on demand. Whereas with a mechanical water pump, the only thing that can increase coolant flow is increasing your RPM. So this helps keep everything in check, kind of where it should be. And as I've said on track, I've really had no issues with cooling or anything like that. I do have an upgraded heat exchanger to keep my IATs down, but I use the factory engine cooling system and I've had no problems with engines overheating. So I think this is a really cool system as long as it works. Yes, there are opportunities to fail. It can get stuck in certain positions. So sometimes you'll see engine codes related to it not hitting its target position or the heat management module getting stuck. And usually that requires replacing it, which would be pulling the intake manifold, getting to all those bolts that you saw me remove, and pulling it off of the water pump housing to replace it with a new one. So that would be a worst case scenario, but generally speaking, it seems pretty reliable. So yeah, as we've said in the last couple videos, we'll continue down this road, taking my B58 engine apart and looking at all the details. I've still got to look at the internals and pull the cylinder head and all of that stuff. So those videos will be coming soon. So stick around for those. But otherwise, I think that's it for this video. So thank you guys for watching, and I hope this helps. And if you have any other questions or comments, leave them down below.